All right, everyone, get ready, because today we're going deep into the world of coding, but not in the way you might think.
Oh,
Yeah, we're going to look at this article called Why Syntax Mastery Isn't as Important as Creative Problem Solving in Coding.
interesting.
And, most people, when they think about coding, they think, well, yeah, you got to know the language perfectly, right?
Right.
But this article, it kind of flips that idea on its head, saying it's more about how you think than, memorizing all the rules.
It's true. It's like you can know all the grammar rules, but can you actually write a good story?
Right, right. So are they saying syntax doesn't matter at all?
Well, no, not exactly. It's more that it's just one part of the puzzle and maybe not even the most important part.
Okay, so there's more to it.
Mm.
Well, I'm definitely interested to unpack this more. One of the things the article mentions is how quickly programming languages evolve.
Yeah.
I mean, it seems like every time you master one framework, there's a new version or
Mhm.
even a completely different language that's taking over.
That's the tech world for you, right? Always changing. Like, think about Python.
Yeah.
The jump from Python 2 to 3, that was a big one.
Oh, yeah.
So many people had to rewrite their code, and even now, like, it's constantly being updated with new libraries, new versions. It never really stops.
So it's not just being like a syntax whiz, it's got to be more than that.
Right.
You need to be able to learn new things all the time.
Yeah, and that kind of leads into another point, the whole idea of transferability. If you only know one language, it's like, only speaking one dialect.
Hmm.
You can communicate within that group, but step outside of it and you're lost.
You're stuck.
Right. But if you've got strong problem-solving skills, those are universal.
Ah, yeah.
So the logic you use to debug a piece of code in Python, that can apply to JavaScript, C++, hey,
So you're training your brain to think like a programmer.
Exactly, yeah. Not
Yeah.
just a specialist in one language.
Okay, so syntax is limited, and it can even become outdated. But doesn't knowing the rules at least help you understand how the code works?
You'd think so, but it's not always the case. You can write perfect code syntactically, but still not really get what's happening underneath?
Hmm.
Think of it like someone who can recite Shakespeare, but they have no idea what the plays actually mean.
So they're just repeating words.
Yeah, without the meaning.
Okay. So someone could be churning out code, but not actually knowing why it works.
Exactly, yeah. And that's where the problems start.
Yeah.
Because if you don't understand the why when something goes wrong, and it will, debugging becomes a nightmare.
Oh, yeah.
And your code's more likely to be, messy, hard to work with.
Yeah. The article also mentions how a lot of the syntax work is being taken over by modern coding tools now. What are your thoughts on that?
Well, it's a game changer, especially for beginners, like IDEs with auto-completion, syntax checking, that kind of thing.
Huh.
It's like having a grammar checker built right in. Catches those little mistakes so you can focus on the big picture.
Yeah, so it's kind of a safety net while you're learning.
Exactly, yeah. And with these tools taking care of more of the syntax, it makes problem-solving skills even more important.
Because if the software can handle the syntax, what separates a good programmer from, just an okay one?
Well, it's those skills. Creative thinking, solving complex problems, writing really elegant code. That's what makes the difference.
Okay, so let's dig into those problem-solving superpowers then. The article lists a bunch of benefits, but adaptability really stood out to me.
Yeah, and in this fast-paced tech world, that's crucial. Imagine you spent years mastering one language and suddenly it's obsolete.
Oh, yeah.
New technology just wiped it out. But if you've got those problem-solving skills, you're not tied to one specific language.
Right.
You can adapt, pick up new things because you understand the underlying principles.
So it's almost like being a chef, right?
Yeah.
A good chef isn't limited to one type of cuisine. They know the fundamentals of cooking.
Exactly. So problem solving is really the foundation for being a versatile programmer.
And being able to adapt like that, it leads to another benefit too, right?
Right.
Designing really good, efficient solutions.
Absolutely. It's not just about finding any solution, it's about finding the best one. Think about it. You could write code that technically works, but it's slow, it's clunky, it's hard to maintain.
Like a car that runs, but it gets terrible gas mileage.
Yeah, exactly. It'll get you there, but there's a better way.
Right, right.
So creative problem solvers, they're like the expert mechanics. They can optimize the code, streamline it, make it run smoothly.
I like that. It's the difference between like a tangled mess of yarn and a beautifully organized, skein of yarn. Okay, so we've got adaptability, efficient design. What about debugging? Isn't that where syntax knowledge really comes in handy?
It might seem that way, but even in debugging, problem solving is king. Look, no one writes perfect code all the time.
Bugs happen.
Bugs happen, right? So when they do, what do you need?
Your detective app.
Exactly. Yeah, you got to trace the logic, look at the clues. It's creative thinking to figure out what's causing the problem.
So you're not just, frantically searching for
Right,
missing
that's-
semicolons.
You're looking for the flaw in your logic, the bigger picture.
It makes me think of that example in the article about optimizing a slow algorithm. They talk about bubble sort versus quick sort.
Right.
And even someone who's not a coder, I get how different methods can make a huge difference.
It's a perfect example. Knowing different sorting algorithms exist, what their strengths and weaknesses are, that's a problem-solving skill. It's not just about memorizing the syntax of one specific method.
It's about choosing the right tool for the job.
Exactly.
So it's like knowing you need to cross a river. You could swim, build a raft, or find a bridge. The best way depends on the situation.
And a skilled programmer, just like a skilled problem solver, knows how to assess the situation and make that call. This is all fascinating stuff, but let's be real for a second. While I love this emphasis on problem solving, isn't there a danger in, going too far in that direction? Doesn't syntax still matter? Of course it does. It's like saying grammar doesn't matter when you're writing a novel. The story's the heart of it, but you still need good grammar to make it readable.
So it's about finding that balance.
Absolutely. Syntax is the foundation.
Yeah.
It's what you build your masterpiece on.
It's like knowing how to use the tools. A carpenter needs to know how to use a hammer and a saw, but that doesn't mean they can build a beautiful house.
Right. You need the vision, the creativity, the problem-solving skills to turn those raw materials into something special.
Okay, this is making a lot of sense. But I'm curious, how do you actually develop those problem-solving skills? I mean, I'm guessing just staring at lines of code isn't going to cut it.
That's where things get really interesting. The article actually goes into some specific techniques and resources that can help you hone those skills.
Okay, that's what I was hoping we'd get into. Let's explore those more in the next part of our deep dive. But before we move on, what has stood out to you so far?
Well, one of the most effective ways is just good old-fashioned practice.
Yeah, makes sense. Like learning to play an instrument, right? You can read all the theory you want, but until you pick it up and actually play.
Exactly. Yeah. Got to get hands-on. And the cool thing is, there are so many resources now to help you practice. The article even mentioned AlgoCademy specifically.
AlgoCademy, yeah, I've heard of that.
They use these interactive challenges almost like puzzles.
It's like they've gamified learning to code.
Yeah, exactly. And that's key because, when you're having fun, you're more likely to stick with it. But it's not just about solving puzzles mindlessly. It's about actively seeking out challenges.
Right, so pushing yourself, trying different approaches.
Yeah, getting out of your comfort zone. And that actually leads to another good technique, breaking down big problems into smaller ones.
Oh yeah, the classic divide and conquer. I use that all the time, even outside of coding.
It works, right. It's like a giant jigsaw puzzle.
Yeah.
If you try to do the whole thing at once, it's overwhelming.
Right.
But break it down into sections.
Much more manageable.
Exactly. And you get that sense of accomplishment as you finish each part. Keeps you motivated. Another thing the article highlights is brainstorming multiple solutions.
So this is where the creativity comes in.
Definitely. The goal is to not just settle for the first solution you come up with. Try to think of as many different approaches as possible.
Even if they sound a little crazy.
Even if they're crazy, you never know what might work. And once you have a few options, you can compare, see which one's best for the situation.
It reminds me of how in coding, there's not always one right answer. It's about finding what's most effective, given what you're working with.
That's a great point. And it leads us to another important aspect, algorithms and data structures.
Now, those sound a bit intimidating for, someone new to coding. What are those exactly, and why are they important?
Okay, so think of algorithms as sets of instructions for solving a problem. Like, they're the recipes for your code.
Okay.
Data structures are how you organize and store the data so it can be used efficiently.
So if algorithms are the recipes, data structures are the ingredients.
Perfect analogy. And just like a chef needs to know which ingredients go together, a programmer needs to know which algorithms and data structures to use.
So it all comes back to problem solving. It's not just memorizing code, it's understanding the tools and how to use them.
Exactly. And the more you learn about these things, the more you expand your problem-solving toolbox,
Yeah.
You start to see patterns, make connections, understand how everything works together. One last technique the article mentioned, which I think is really helpful, is analyzing other people's solutions.
Oh, so learning from the masters.
Exactly, just like an art student studies the great painters.
Yeah.
Websites like GitHub are full of code examples. Don't be afraid to dive in, see how others have solved similar problems.
It's like having a mentor guiding you, kind of.
Right. So we've talked a lot about the how of problem solving, but what about the future? The article had some interesting predictions about how coding education might change. What were your takeaways there?
Well, one of the big ones was the focus on computational thinking.
Yeah.
We touched on it earlier, but can you explain a bit more about what that is and why it's important?
Sure. So computational thinking, it's basically approaching problems the way a computer does.
So thinking like a computer scientist.
Yeah. Breaking down complex problems into steps, finding patterns, designing solutions. And the great thing is, it's not just for coding.
Right. It's a skill you can use anywhere.
Exactly. So teaching students this, it prepares them for anything, not just tech jobs.
It's like giving them a set of mental tools they can use for any challenge.
Yeah, exactly. And this ties in with another prediction, the role of AI in education.
We're already seeing it with platforms like AlgoCademy, right?
Yeah, they use AI for personalized feedback and guidance. But I think it's going to get even more advanced. Imagine AI tutors that can analyze your code, give you suggestions, even change how they teach based on how you learn best.
So it's like having a coding expert available all the time.
Exactly.
Yeah.
And that could make learning to code so much more accessible for everyone. The article also mentioned the move towards more project-based learning.
I really like that idea. It's one thing to learn about coding in theory, but to actually apply it.
Yeah, that's where it gets real. It's like reading about how to build a house versus actually building one.
Right.
Project-based learning, you get to see the results of your work.
It's much more motivating.
And you learn to work with others, which is huge in any field. Finally, the article talked about cross-disciplinary coding education.
What do they mean by that?
So, integrating coding into other subjects, science, math, even art and humanities.
Oh, so breaking down those walls between subjects.
Exactly, showing students how coding can be used in anything. Imagine using code to create simulations in science class or make art in art class.
It's about showing them the possibilities.
Exactly, and making it more relevant to them. So the future of coding education, it's really about empowering students to be creative problem solvers, adaptable thinkers.
It's giving them the skills to make a difference in the world.
Yeah, and that's a future I'm excited about. Before we wrap up this deep dive, what are your thoughts? What resonated with you the most?
You know, I think what really struck me is how this article changes how we see coding. It's not this super technical, intimidating thing anymore.
Right, it's more approachable, more about creativity and thinking logically.
Yeah, exactly. It makes it feel like anyone could be good at coding. Oh, and speaking of thinking logically, that idea of computational thinking really stuck with me. It sounds like a superpower, not just for coding, but for anything.
It is. It really is. It's like a mental framework for any problem, no matter how complex. You break it down into smaller pieces, look for patterns, create a plan. Imagine a tough task at work, nothing to do with coding. You could still use that approach.
So it's like a mental algorithm for problem solving in any situation.
Exactly. And the more you use it, the more natural it becomes. It's training your brain to be a problem solver in everything you do.
It makes you realize how coding skills can actually help you in other parts of life, too.
Yeah.
It's not just about building software. It's a way of thinking that can benefit you in so many ways.
Absolutely. And that's why I'm so excited about the future of coding education. Imagine if we taught everyone computational thinking right from the start. It would be like basic knowledge alongside reading and writing. It would give future generations such powerful tools to deal with, all the challenges they'll face.
It's like giving them a mental Swiss Army knife, ready for anything.
Yeah, exactly. And then on top of that, we have AI coming into education. Those personalized tutors, the ones that can guide you, give feedback, adjust to how you learn best.
It's like having your own coding mentor, available 24/7.
Right. And that could make learning to code so much easier and more fun for everyone. Imagine anyone, no matter who they are or what they've done before, could learn to code, could unlock their creative potential.
That's a future I can definitely get behind. And speaking of potential, I love the idea of project-based learning becoming more common.
Yeah, it's such a great approach. It takes you beyond just theory and puts you right into real-world problem solving.
It's like instead of just reading about building a table, you actually build one.
Exactly. You learn so much more when you're actually making something.
Yeah, and the feeling you get when you build something that works, with your own code. That's got to be amazing.
It is. It's so rewarding. And you learn to work as a team, which is a crucial skill no matter what you do.
Absolutely. And then there's that idea of, cross-disciplinary coding education.
Yeah, bringing coding into other subjects, like all those walls between subjects just disappear.
I love that. It shows students that coding isn't just one thing. It's a tool they can use in so many different ways.
Exactly. Imagine using code to create simulations in history class, or to make music in music class, or design clothes in art class.
The possibilities are endless.
Right. It's all about helping students think outside the box, solve problems in new and creative ways.
And who knows what amazing things they'll come up with. It's a really exciting time to be in the world of coding and education in general.
Yeah, it feels like we're right on the edge of some big changes.
And it all comes back to that shift we talked about, from focusing on syntax to focusing on creative problem solving. That's what's going to unlock all this potential, make it possible for anyone to become a coder, a creator, a problem solver.
I couldn't agree more.
Well, folks, I think we've officially reached the bottom of this deep dive. We've explored a lot of fascinating ideas today. And while knowing the syntax is definitely important, it's clear that creative problem solving, that's the real heart of coding. The best part is anyone can learn these skills. With practice, with persistence, and with curiosity, anyone can become a better problem solver. So as you go about your day-to-day, think about those coding-inspired approaches we talked about. Could you use them in your own life? Could you break down a tough task? Brainstorm different solutions. Find a better way to do something. Remember, the power to solve problems creatively, that's not just for coders, it's for everyone. Keep exploring, keep diving deep, and keep those problem-solving muscles working.